Okay, so the last thing in this section is still we talked about yesterday. We talked about maximum and minimums, right? So we talked about finding critical values, right? That's where the derivative equals zero, or the derivative doesn't exist, right? Horizontal lines, horizontal tangent lines, vertical tangent lines, and then we talked about the first derivative test. That tells us where the function is increasing, where it's decreasing, and where it's not doing either. Okay, so the that's the test we use, right? The first derivative test. Okay, and then we found some critical numbers. We found where it was increasing, decreasing, and found maximum minimums, right? Okay, that's what we did yesterday. Today we're going to do the same thing, except now we're going to focus on not relative. We're going to focus on absolute. We're going to focus on absolute maximum minimums. So the top, very top of a function, the highest y value or the lowest y value. Okay. So to do that, we use something called the extreme value theorem. Extreme value theorem, EVT, states that if a function f is continuous on a closed interval, has to be on a closed interval, then f must have an absolute maximum and absolute minimum at least once. So if it's an continuous and on a closed interval, means it goes from here to here, not from negative infinity to positive infinity. It has to have one of each, at least one of each. Okay. So today we're going to focus on the absolute, or sometimes you'll see global. It's called global maximum, global minimum. I rarely see that, mainly in old textbooks, but sometimes you will see global. It's the same thing as absolute. Okay. So what we're going to do here, we need to check. We need to check the beginning of the interval, the end of the interval, and any critical points. So that's step 2 on the board. We're going to make a table. Whichever one has the highest y value is the absolute max. Whichever one has the lowest is the absolute min. Okay? So we're essentially going to do the same type of thing, just a little bit different. All right, so let's look at our first problem. So given f of x, determine the absolute maximum of f from on the closed interval -5 to -1. So only from -5 to -1. We don't go past -1. We don't go past -5. Okay, only from there to there. We include -5 and -1 because it's closed, but we don't go past it. Okay, so first thing we need to do is find the critical values, just like yesterday. We need to find those critical values. Okay, so we're going to do what we did yesterday. Critical values exist when the derivative equals 0. Okay, so find the derivative. Don't look up here. You know how to find derivative. Okay. Okay. Now set it equal to 0. We did that yesterday too. So do that tomorrow. Do that too. When you're taking notes, make sure you test yourself, right? If you're just waiting up here to look to see what I do, what do I do? What do I do? Don't do that because then you're not testing yourself. Okay. Solve that. Solve that. You guys have done that as math too. What are the x values? We did that yesterday. Okay. If you don't know, the directions are on the board right there. Factoring trinomials. That's the steps we do. That's what I teach in math 2 and math 3. Okay. It's already equal to 0. It's got a GCF, so I'm going to divide by the GCF. Okay. That leaves x squared plus 6x plus 9. So now I need to find the two numbers that multiply to be 9, but add up to be 6. Plus 3 and plus 3. Okay. Solve it. Set them all equal to 0 like we did yesterday, right? plus 3 equals 0. Well, two of them are going to get the same answer. One of them, negative, or 3 is not equal to 0. That's just not a true statement. So we don't have to worry about that, but we do get negative 3 twice. So we get one critical value, and it's at negative 3. Okay, that's our critical value. We only have one critical value in this problem. Okay, we did that yesterday, so the steps stay the same. All right, step 2 is going to be different though. Step 2 is different. Step 2 says make a table. All right, I don't have to do the first derivative test. I'm going to use a table instead. Okay, so the table, if you can see on the board, looks like this. It's not the first derivative test. On the table, I'm going to check 3 things. First thing is the beginning of the interval. Where's the beginning of the interval? Negative 5. So I'm going to check that. I'm going to check the end of the interval. Negative 1. And any critical values. In this case, I only have 1. Okay. Whichever one has the biggest y value wins. Whichever one has the lowest y value also wins. There's going to be one that has a y value in the middle. We don't want that one. Okay? Actually, no. We're only looking for the maximum. So I only care about the one with the highest y value. That's the winner. So what do I get? How do I find the y values? Yeah, Arthur? There you go. Because it says f of x on top. It says f of x right here. We're going to plug it into the original. Okay, we can't use calculators. So we're going to do a little math. So everywhere I see an x, I'm going to plug in a negative 5 first. Okay, so I get negative 5 cubed is negative 125. Negative 5 squared is 25 times 9 is 175. 27 times 5 is negative, 27 times negative 5 is negative 185 plus 3. Yeah. Yep, you're right. You are right. 225. All right, let's see what we get. So if I add these two guys up, I get 100. Subtract 185 is negative 185 plus 3 is negative 180. Sorry, negative 82. Okay. Do the same thing for negative 1. Negative 1 cubed plus 9 times negative 1 squared plus 27 times negative 1 plus 3. So that's negative 1 plus 9 minus 27 plus 3. 8 minus 27 is negative 19. Negative 19 plus 3 is negative 16. Okay. So far, the highest y value is negative 1. Well, let's try the last one. Let's see. So negative 3 cubed plus 9, negative 3 squared plus 27 times negative 3 plus 3. So negative 3 cubed is negative 27. Negative 3 squared is 9 times 9 is 81. 27 times 3 is 81. Is that 81? Yeah. Plus 3. 81s cancel out. I have negative 24. Good. Same. You guys got the same? Double check my math because I'm kind of going fast. Yeah. 27 times where? Oh, right here. 135 up here. Oh, okay. Sorry, up here. Okay, let me see. 135. So that's going to change things a little bit. Let's see. 135 plus 3. So that's negative 35 plus 3 is negative 32. Is that what you got? Okay. All right, so we're good now. So we're looking for the absolute maximum. Well, according to our notes, the absolute maximum is the one with the highest y value. Okay. So they're all negative, but there's one that's the bigger than the other, right? And that's negative 1. So we'd say absolute max at x equals negative 1. Okay. So the absolute maximum for that interval would be, the maximum point would be this right here. Well, when they say absolute maximum value, they're usually just talking about the y value. So if they're talking about the y value, negative 16. When you talk about maximum minimums, if they're asking for the if they said what x, like up here, they said what x coordinate is all relative minima, then you would give the x coordinate. But if they're just wanting the absolute maximum value, that's usually the y value. Okay, that's usually the y value. So make sure you put that in the note, in your note, that they only want the y value, the highest y value, which is negative 16. Okay. All right, so I want you to try number 5. Try number 5 on your own. Okay, so I found derivative, set it equal to 0. It's a binomial. So binomials, if it's a binomial, we start with GCF. If it has a GCF, factor out the GCF. It does. It has a pretty big GCF. Negative 4x squared, which leaves x minus 3. Took away the GCF. They had a lot in common, so that didn't leave a lot. Okay. Set those both equal to 0. Divide by negative 4. Square root of 0 is just plus or minus 0, but it's the same thing. Plus or minus 0 is the same thing as just 0. So I got 0 is a critical value. And then I get 3 is a critical value. So 2 critical values, 0 and 3. Make sure they're both inside the interval, because sometimes you'll get a critical value and it's not within the interval. 0 and 3 are within the interval, so it's not a big deal. But sometimes you'll get a critical value and it's outside this interval, and you'll check it anyway, and it might, if you get that one as a maximum or minimum, it might throw you off. So make sure it has to be within the interval. Luckily, these two are. If it's not, if one of them is not within the interval, don't test it. Don't put it in your table. Okay. Okay, so we're going to test the beginning, the end, and the critical values. We're going to test all of those guys to see which one has the lowest y value, smallest y value. Okay, so it's got a negative x to the fourth plus 4x cubed plus 8. Okay, so I'm going to plug in -2 first. When I plug in -2, I get positive 16, but then with the negative out in front, that makes -16. -2 cubed is -8 times 4 is -32 plus 8. So I get -48 plus 8, which is -40. Plug in +4 now. 4 to the fourth is 64. So -64. 4 to the third is, wait, no, that's 64. Yeah, that's 64. 256. Thank you. Plus 8. Okay, I'm looking for the lowest y value, so I'm looking for something that's really low. This one might be the lowest. Let's see. -256 plus 64 is -192 plus 8, -180. Yeah, it's a 256 again. That's right. 256. So, okay, so luckily these cancel out. Nice. So they cancel out. 256, 256. So yeah, it just leaves 8. Okay. 0. 0 is nice because everything cancels out. So you get 8. 3, +3. So +3, 81. So this is -81 plus another 81 plus 8. Mhm. Oh, 27 times 4. Sorry, 27 times 4. What is 27 times 4? 27 times 4? A little lower than that. 108, yes. Okay, so 108 minus 81 is 27. And then 27 plus 8 is 35. Okay. Looking for the minimum. So the minimum is the lowest value, which is -40. So when x equals -2, that's the absolute min. So what is the absolute minimum value? -40. -40. Where does that happen? At -2, -40. Okay. At the beginning of the interval. All right. Okay, we got one more left. One more. Okay, so I want you to find the both, the absolute maximum and the absolute minimum. Okay, so I'm going to give you some time to do that. Okay, found derivative. Derivative is 6x over x squared plus 3 quantity squared. That's the derivative. Okay, now we have to set that equal to 0. Well, when you're looking for critical values, we talked about this yesterday. Actually, we talked about it just earlier today. We check where the function equals 0, where the derivative equals 0, and where the derivative doesn't exist. Okay, for critical values. So let's go back here. To make this 0, which part would have to be 0 for this guy to be 0? The numerator. So we're going to set the numerator equal to 0. And then for it not to exist, the denominator would equal 0. Sometimes they'll say, test question, they'll say, this is your first derivative. And they'll say, tell me where you have horizontal tangent lines. What would I check? How do I find where this guy has horizontal tangent lines if this is my first derivative? Exactly, but only where? The top. The top, right? I wouldn't need to set the bottom for, remember, horizontal tangent lines means 0, right? That's just the top. Okay? If they said vertical tangent lines, because they could say vertical tangent lines, you would set the bottom equal to 0. If there is no bottom, like the derivative we had earlier, like this derivative here, this derivative does not have a denominator. So there would be no vertical tangent lines. There could be horizontal at 0 and 3. Okay? That's a big question you're going to start seeing. Tell me where the horizontal tangent lines are. Tell me where the vertical tangent lines are. Okay? It's doing exactly the same thing, just saying it differently. Okay, so divide by 6, you get 0. What about the other guy? Yeah, don't even try it. Because any number I plug in will not give me 0 as an answer. We learned that yesterday. So it's never going to equal 0. That guy's never going to equal 0. So we get one critical value at 0. And luckily 0 is inside the interval. Okay. Check the beginning. Check the end. Check any critical values. Okay. So I'm going to plug in -1. -1 squared, +1 squared plus 3. So I get 1 over 4. Okay. I don't even have to plug in 1 because I'm going to get the same answer. 1/4. And 0, I can do that one in my head. What am I going to get? 0. Okay. So the absolute maximums are at 1 and -1. Those are the highest points. We have 2 of them. The absolute minimums, there's only 1. They are at 0. Absolute max, absolute max, absolute min. Okay. So two absolute maxes, two absolute minimums. All right. Okay, I'm going to give you, since we have some time, I'm going to give you at least one more problem. Again, it's worded a little differently because you're going to see things worded differently, but it's all the same. Okay. So if you have some space on there, great. If you don't, you can use a separate sheet of paper. Let's see here. That was example number 6. Let's call this example number 7. Okay, let's see. Okay. Find all intervals on which f of x is increasing. Okay. X to the 4th minus 4x cubed plus 9. Find all intervals on which f of x is increasing. 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 Okay, so where the function is increasing, we go back to yesterday, and we have that's the first derivative test. First derivative test tells us where it's increasing and decreasing. So first derivative test, number 1 says if the derivative is positive, it's increasing. If the derivative is negative, it's decreasing, and if it's 0, then it's a critical value. So we have to use the first derivative test. Okay, so we find the derivative, 4x to the 3rd minus 12x squared. Set it equal to 0. So we factor out 4x squared, and I get x minus 3. Set those equal to 0. And you get 2 critical values. You get 0 and positive 3. Okay, 0 and positive 3. Okay, those are the critical values. That's where a maximum or minimum are going to occur. But we need to know, the question is asking, where is it increasing? So we have to use the actual first derivative test. So we have to check at 0 and 3, it's not increasing or decreasing because those are critical values. But in between those, it's either increasing or decreasing. So we're going to do what we did yesterday. Check a value in between 0 and 3. Any value in between 0 and 3. 1, 2, 2.5, 1.5, 0.7, whatever you want. I'm going to try 1 since 1 is probably the easiest number in between there. So I plug it into the derivative. And I just want to see if I get a positive or negative number. That's all I'm checking for. Okay, so I get 4 minus 12, which is a negative 8. So I know that everywhere in between those two values, it's going to be decreasing. It's not what I want, right? I want increasing. So let me check after 3. So any number after 3. 4, 5, 6, 12, whatever you want, okay? I'm going to check 4. So 4 cubed minus 12 4 squared. So 4 cubed is 64, times 4 is 256, minus 4 squared is 16. 12 times 16, let's see, is 192. Okay. Don't really care what the number is. I just know it's going to be positive. It's going to be positive 60 something. 64. Okay. So here it's going to be positive. Now I need to check less than 0. -1, -2, -10, -50, whatever you want to check, less than 0. I'm going to check -1. So 4, -1 cubed minus 12, -1 squared. So -1 cubed is -1 times 4 is -4, minus 12 is -16. -16 is negative. We've never seen that before. Just trying to make sure my math is right. It's possible. So it's not like I did a mistake. Okay. I'll show you how it's possible. I'll give you a picture of something that's possible like that. So it's actually negative from negative, it's decreasing. So I should say decreasing. Continues decreasing and then increases here. So the only place it increases is from 3 to positive infinity. So let me write that down before I forget. Increasing from 3 to positive infinity. Here's my question. We've never seen one like this. Usually at the critical values, they change. So what is that going to look like? So is it, is it going to, so it's going to decrease here. So decrease means go down. And then what happens at 0? Not at 0. At 0 flattens out, right? And then what happens after 0? Continues decreasing. And then at 3? So it's going to look something like that. Where it has a little hiccup at 0, but it still decreases. It continues on its path. Okay, so it's probably going to look something like that. Okay, that's what it looks like. It's possible. There's something that looks like that. If you don't believe, a good thing to do, check your answer. The easiest way to check your answer is probably on Desmos. Graphing calculator. For x to the 4th minus 4x cubed. Let's see, y equals x to the 4th minus 4x cubed. Plus 9. Oops. See, there it is, the hiccup at 0. When x equals 0, the little hiccup, it decreases, hiccup, keep decreasing, and then at 3, it'll go back up. Yeah. Yeah. So it's possible. So that's what I get students do that all the time. They try to do shortcuts. They're like, okay, so I know it's increasing over here and decreasing over here. So that means it's got to be increasing, right? So I'm not even going to have to check, right? That can get you sometimes. Those sneak up on you. So make sure you actually check to see if it's increasing or decreasing. Don't assume that it switches back and forth, back and forth, back and forth. Okay? All right, I'm going to give you one more. We'll be done. One more, we're done. This is example number 8. Find all horizontal tangent lines for let's see, where is it? It's right. X to the 4th minus 16x cubed plus 22x squared minus 8. So I want you to find all horizontal tangent lines for that guy there. So remember, horizontal tangent lines means where the derivative is 0. That's all it's saying. Where is the derivative going to be equal to 0? Well, find the derivative, set it equal to 0. Okay, so that's what I did. It was a trinomial, factored out of GCF. So now I got to factor x squared minus 12x plus 11. So it's going to be minus 11 and minus 1. Set them all equal to 0. Move over here. So I get 4x equals 0. X minus 11 equals 0. X minus 1 equals 0. Divide by 4, x equals 0. Add 11, x equals 11. Add 1, x equals 1. Those are the 3 spots I will have a horizontal tangent line, because those are spots where there's a maximum or minimum. Okay. Will this guy have any vertical tangent lines? I didn't ask that question, but I could. Will F have any vertical tangent lines? Because there you go. The denominator is 1. The denominator is 1. So if the denominator is 1, it can't ever equal 0. So yeah. Only time we can have vertical is when there's a denominator and when that equals 0. Okay. So they changed the wording, but it's all the same. Okay. It's all the same. All this stuff's the same. So tomorrow what I'm going to do is I'm going to give you some time to work on the assignment. I'm not going to post the assignment today. I'm going to give you some time tomorrow. So I'll have the assignment in, let you guys work on it tomorrow. Okay. And then Thursday we'll go on to the next lesson. Okay. So I'll give you guys some time to practice, ask questions, all that stuff tomorrow.